I hope I solved it.
Remember when equations looked like that? 2x plus 3 is equal to 5?
Yeah.
What's the answer?
1.
1, right? Pretty easy to see that, isn't it? Like you could actually go through a guess and check process and see what that is. I remember when I taught a different class, people would they kind of scoff at math because they're like, those problems are easy. I don't have to show my work. I already know how to do all my math. It's not very difficult for a math teacher to make problems that are a little bit more challenging than that. Are you able to look at that and see what the answer is? No. And that's why you must follow a process. You must understand the steps. And when we are solving rational equations, it looks super complicated. And for many of you, you might say, this is a spot on the test where I'm just going to take a 0. Don't do that, because we're going to take something that looks super complicated and we're going to make it super easy, okay? And before you say, well, Gens, you're saying it's super easy, that's because you're good at math. Folks, if you can do this one thing, find the common denominator, then this can be super easy. If you can't find the common denominator, then no, it's not going to be easy for you, okay? So I believe that everybody here can find the common denominator. For example, what do 6k squared, ,3k squared, and k, what can they all multiply to?
6k squared.
They can all multiply to 6k squared. Once I identify a common denominator, the rest is going to be pretty easy. Notice how this one has a 6k squared in the denominator, so it's done. I don't need to do anything else with this. But the 1 over 3k squared, what am I going to have to do there? Multiply the top and the bottom by 2. Then it says minus 1 over k. What would I have to multiply k by to make it a 6k squared?
6k.
Multiply the top and bottom by 6k. We're going to pause and we're going to look. Notice that this is a 6k squared. Notice that 2 times 3k squared is 6k squared. And k times 6k is a 6k squared. Everybody agree we have 6k squared? At this point, you may now completely ignore the entire denominators and simply just look at the numerators. So we have 1 equals 2 times 1 is 2 minus 1 times 6k is 6k. So I told you we could take something that looks super complicated. If we just identify the common denominator, we could create an easy equation. I know how to solve 1 is equal to 2 minus 6k. What do I do to both sides? I subtract 2, and I get negative 1 is equal to negative 6k. Now what do I do to solve for k? Divide by negative 6. And end up with k is equal to 1/6. That's the answer. Yeah. Yep. Yeah, if you guys have pictures, you just go. I know we all pass it, and you just go do your thing. Okay, spend 10 seconds, talk to your peer. What's the common denominator for number 2? What's the common denominator for number 2? Go. Call it.
Do you have to make something under water? Yeah. Okay. Yeah.
Okay, I heard a lot of people say it. The common denominator is 5x. So therefore, I multiply the top and bottom of this by 5. Notice this middle one, 6 over 5x, does not get multiplied by anything. But 1 over 1 gets multiplied by 5x over 5x. Are the denominators now the same? So we may ignore them. What do you have on the left-hand side? 5 equals, then what? 6 plus 5x. So it becomes a very basic linear equation. We subtract the 6, and we get -1 is equal to 5x. Divide by 5, x is -1/5. We do 2 more problems. On your assignment, you only have 4 problems. Okay, nice and short. For this problem, I'm first going to factor the denominator to be m times m minus 1. That is already factored, this m times m minus 1. So notice one of them has an m, 2 of them have an m times m minus 1. So what's the common denominator? M times m minus 1. So my first one is 1 over m times m minus 1. Oh, sorry, I switched to x there. My bad. Okay. Do I need to multiply top and bottom here by anything?
No.
How about here?
Yeah.
By what, Carly? You got it. Now how about here? 1 plus m minus 1 equals 5. What do you notice?
One's canceled.
The 1's cancel, I get m is equal to 5. Our last example for the day would be number 4. I'm going to factor this first to be x times x plus 2. So one side is just a 1, so there's a 1 over 1. There's nothing in the denominator. The other one has an x in the denominator, and this one has an x times x plus 2 in the denominator. So what is the common denominator?
X and then x plus 2.
Yep, x times x plus 2. Notice that the middle term already has an x times x plus 2. So what does this side need?
X plus 2.
X plus 2 over x plus 2. What does this side need?
X times x plus 2.
X times x plus 2. And at this point, again, it looks like a big jumbled mess. And I get it. But once the denominators are the same, just focus on the numerators. So if I focus on this numerator here, notice how I have, anything times 1 is itself. X times x is my x squared. X times 2 is 2x. Then I have an equal sign. I have 1 plus, now I'm going to need to multiply this out. And I get x squared.
Minus x.
So it's a minus x and then a positive 2x. What's that going to make if I do a negative x and a positive 2x? Positive 1x. And then a negative 1 and a times positive 2 makes negative 2. So we multiply that out. That's what we get. Uh-oh, this is different because x is to the second degree. How do you solve an equation when x is the second degree? You get everything
On the same side.
on the same side, okay? So I'm going to gather everything on the same side. So I'm going to subtract this x squared over here. Hey, what do you notice? There's an x squared on both sides. What's going to happen? Those do reduce to 0, and I'm left with a 2x is equal to, I have 1 minus 2 is negative 1, and I have a positive x. So now we just have a linear equation, meaning it's x to the first power. Those are easier to solve. All we have to do is move the x over to the other side. I subtract the x, and I have a positive, sorry about that. What's 2x minus x?
X equals -1.
1x, and I have a negative 1. That's my solution.
Wait,
What about the 2?
yeah, why wouldn't you subtract 2x?
So I have 2x minus 1x, and 2x minus 1x is equal to 1x.
I'm talking about that 2.
Oh, this 2? I'm sorry, I did negative 2 and positive 1. I combined those like terms together, and I got negative 1 out of that. Is that better? All right, so you have 4 problems. Answer key is up on the board. I'd like to help you with whatever you need help with. You have the rest of the time to work, which is quite a bit.